Alright, we're dealing with 8-6 here. We're going to use similar figures to solve some things for indirect measurement. I just want to remind you that similar polygons are polygons that have the same shape but different size. And with that, their corresponding angles are congruent and their corresponding sides are proportional. Alright, now we have a problem right here. Example 1 says find the value of x. Notice it doesn't say anything about similar figures. They're not going to lead you down that path most of the time. You just have to have that in your toolbox and know when to use it, when it's going to be helpful. So what I want you to notice here is that we have two triangles in this picture. We have this little triangle right here. And then we have the larger triangle right here. So, as I'm looking at these two triangles, I would want you to notice that they both have right angles. So that's one pair of congruent angles. And then both triangles are sharing this angle. It's the same angle for the little triangle as it is for the big triangle. So that right there is another pair of congruent angles. So we learned 3 ways to prove triangles are similar. And angle was one of those. And so right here you got 2 pairs of congruent angles. So by angle similarity, I know those two triangles are similar. And once I know the triangles are similar, then I know their corresponding sides are proportional. So I know that if I want to find out what x is, which is labeling a side, I know I can set up a proportion to make that happen. Now, for some people, you can look at this and you can see what corresponds with what real easily. For some people, it's a little bit harder. So one thing that might be helpful for a few of you is to just redraw these triangles separately. Some of you, this might be a waste of time, but for some of you, this could really help. So I'm just going to redraw that triangle and then redraw the big triangle. And then that might allow you to see the different parts of the different triangles and how they correspond with each other. So the x corresponds with 5 from the other triangle. Now, since I put x in the numerator, 22 needs to go in the numerator. We make sure when we're setting up these proportions that all the sides from one figure go in the numerator and all the sides from the other figure go in the denominator. And the 22 corresponds with 10. So there is our proportion. We set that up because we knew the triangles were similar, therefore their sides are proportional. So we set up the proportion, and then we can cross multiply to solve that proportion. So I'm going to cross multiply. 10 is multiplying times x. 5 is multiplying times 22, which is 110. And those cross products are equal to each other. Now, with a simple proportion like this, there are shortcuts where you can just do 5 times 22 divided by 10. But I'm going to do it the longer way each time just so we know how that works when we have more complicated proportions. We just take those two cross products and set them equal to each other, and then we solve that equation. So x is being multiplied by 10. If I want to solve for x, I'm going to divide by 10. We'll find out x is 11. Alright, we do the same basic process with example 2. Remember, I can't start out knowing that the sides are proportional. I need to know that we have similar figures before I'll know that their sides are proportional. Notice the two triangles going on here. Again, you have this little triangle right here. And you got the larger triangle right here. Alright. Those two triangles are sharing an angle just like they did on the last problem. They're sharing this angle right here. That angle is the same size for both of them, so that's a pair of congruent angles. Then notice these arrows here. These arrows tell us these lines are parallel. And anytime we have parallel lines, those can help us find congruent and supplementary angles. For all the angle pair relationships we learned when we have a transversal through parallel lines. So for some people it helps to extend them. Here's a pair of parallel lines, transversal. These angles are corresponding angles. And corresponding angles are congruent anytime the lines are parallel. Now that's enough right there to say the triangles are similar by angle. We got 2 pairs of congruent angles. But I could also find out, based on these same parallel lines, with this transversal, these are also corresponding angles. So they are also congruent. So while I don't need all 3 pairs of angles, I could find all 3 pairs of angles are congruent. So If you would like to redraw the triangle, you can. If you can see the corresponding parts in the two separate triangles easily enough for yourself, then you don't need to spend time doing this, but for some people it is helpful. So there's our two triangles. So since I know the triangles are similar by angle, I know their sides are proportional, so I'm going to set up a proportion to solve for x. So x corresponds with 8. And since x went on top, 6 will go on top. They're both in the numerator. 8 went in the denominator, so 3 goes in the denominator, and 3 corresponds with the 6. So there's our proportion, and all we got to do is cross multiply now. 3 times x, 8 times 6, and there's our equation to solve. X is being multiplied by 3, so we divide by 3. All right. So we're going to be using this concept here, dealing with similar triangles here, and knowing that their corresponding angles are congruent, their sides are proportional. We're going to use that in indirect measurement. So indirect measurement is when you want to measure something, but it's not something you can measure with a ruler or tape measure. So we're measuring it indirectly. We're not directly measuring it. So if I want to measure the height of a skyscraper, I'm not going to grab a big tape measure. If I want to measure the height of a mountain, I'm not going to grab a ruler. We got to have other ways to figure out what those heights are, what those distances are. So here is a situation we can use. Okay, I would want you to notice, just like in these other problems, you have a triangle right here, and you have a triangle right here. And those triangles are sharing this angle right here, so that's a pair of congruent angles between those two triangles. And something that's not explicitly said here, but when we're talking about the height of a tree or the height of a building, height is always perpendicular to the base. And in these types of problems like this, the base is the ground. So the height of the building and the ground are going to be perpendicular to each other, which means they form a right angle. And the height of the tree is going to be perpendicular to the ground. So they're forming a right angle. So now when I look at the little triangle and the big triangle, they both have right angles. That's a pair of congruent angles. And they're sharing this angle. That's your second pair of congruent angles. So by angle, I know these triangles are similar. If you want to redraw the triangles, you can. On this triangle, I have side lengths of 21 and 24. And on the green triangle, I have sides of x and 56. And we want to set up a proportion, because as soon as we know the triangles are similar, we know the sides are proportional. So the x corresponds with the 21. The 56 corresponds with the 24. Again, both of these sides are in the numerator, both of these sides are in the denominator, and I have corresponding parts paired up in each ratio. So I'm cross multiplying. X times 24. 21 times 56 is 1,176. And there's the equation I'm solving. X is being multiplied by 24, so I'm dividing by 24. And the units over here were in meters, so the height of that building is 49 meters. All right, let's look at the next problem. All right, so the change here now is, so far we've kind of used our skills for similar figures, but the picture's always been set up for us. So we're making that one simple extension here. We've got to read the problem and set up the picture for ourselves. After that point, everything else will be the same. All right, so example 4. When Stephanie stands 2 feet from a lamppost, her shadow is 3 feet long. So here is Stephanie. And here is the lamppost, and it says she's standing 2 feet from the lamppost. And if we understand how a shadow works, you have a light source, and our body, or whatever it is that's creating the shadow, blocks that light and creates the dark space on the ground. So the light from the lamp comes just over her head and hits the ground over here, and so it's light over here, but when the light comes right here, it hits the body, and no light is able to get to this space. So this space right here is where the shadow is, and it said her shadow is 3 feet long. So here's Stephanie standing 2 feet from a lamppost, and her shadow is 3 feet long. If Stephanie is 5 feet tall, how tall is the lamppost? Alright, so again, anytime we're dealing with height is always perpendicular to the base. So how tall is the lamppost? We don't know what that height is, perpendicular to the ground. Stephanie's 5 feet tall, that's perpendicular to the ground. And then I want you to notice, just like in some of these other problems, you have this triangle, and you have this triangle, and those two triangles are sharing this angle as well. So the small triangle and the big triangle both have right angles. That's a pair of congruent angles. They're sharing this angle. So there are two pairs of congruent angles there. And so by angle similarity, I know these triangles are similar. Therefore, their sides are proportional. So again, if it's helpful for you, you can redraw the triangle. So this triangle, you got 5 and 3. And for the other triangle, could be tricky for some people. This side is x. Look closely at what this side is. You've got to add those two parts together to get the length of that side. So there are our triangles redrawn, and we know their sides are proportional because they're similar. So we're going to set up our proportion. So x corresponds with 5, and 5 corresponds with 3. So the x and 5 are both from the same figure. They're both in the numerator. 5 and 3 are both from the same figure. They're both in the denominator. And we have our corresponding parts matched up in each ratio. So there is our proportion, and all we have to do is cross multiply. So 3 times x and 5 times 5. And remember, when we cross multiply, we're just setting those cross products equal to each other and then solving the equation. So x is being multiplied by 3. Then I need to do the opposite and divide by 3. Now 3 does not go into 25 evenly. So I need to check the directions about what to do with this answer, and it says round to the nearest hundredth. So we remember there's 2 zeros in the number 100, so when it says round to the nearest hundredth, that means I'm keeping 2 places after the decimal. That next number is a 3, which is not big enough to round up, so I'll leave it as 8.33. And the units here were all in feet. So the height of that lamppost is 8.33 feet. All right, let's try example 5. All right, a tree cast a 36.5 foot long shadow. So first thing I'm doing, I'm drawing a tree. And the sun's up here somewhere bringing down its rays. And it creates this shadow right here that is 36.5 feet long. At the same time, there is a 28-foot flagpole. And that same sun is creating a shadow on the flagpole. It's a 28-foot tall flagpole that casts a 14-foot long shadow. And we want to find the height of the tree. Now it is important that they mention that they are close together or that it is the same time of day, because if it's a different time of day, that would affect the shadow, the length of the shadow, or what part of the world you're in at that time of day would affect the length of the shadow. So we want to say something about them being close together or the fact that it's the same time of day. So how that helps is, if they're close together, it's the same time of day, then it should be the same angle of elevation to the sun in both situations. Should be the same angle up to the sun. The sun's hitting them both at the same angle. And then remember, height is always perpendicular to the base. So the height of the flagpole, height of the tree, forming right angles with the ground. So there is our picture. And again, because there are 2 pairs of congruent angles, then by angle, I know these triangles are similar. Therefore, their sides are proportional. So I'm going to put the height of the tree over the height of the flagpole, because those correspond. X and 36.5 come from the same figure, so they're both in the numerator. And the 36.5 corresponds with the 14. So there's our proportion. And all we got to do is cross multiply to solve. So I got 14 times x, and I have 28 times 36.5. And there's the equation, and I just need to solve. X is being multiplied by 14, so I do the opposite and I divide by 14. And all these units were in feet, so the height of the tree is 73 feet tall. All right, last one. Let's look at example 6. It says a mirror is on the ground 8 feet from Ricky and 19 feet from a flagpole. Alright, so here's Ricky. There's a mirror on the ground that is 8 feet from Ricky and 19 feet from a flagpole. So there's a mirror on the ground 8 feet from Ricky, 19 feet from the flagpole. Ricky can see the top of the pole in the mirror. So Ricky looks into this mirror, and what he sees in the mirror is the top of the flagpole. Alright. Ricky is 6 feet tall. How tall is the flagpole? Alright, so once again, height is always perpendicular to the base. So when we talk about Ricky being 6 feet tall, that height is perpendicular to the ground. When we want to know how tall that flagpole is, it's going to be perpendicular to the ground. And if we know how a mirror works, whatever angle the light goes into the mirror, it comes out the mirror at the same angle. So that means that these angles right here are going to be congruent. That light from the flagpole is going into the mirror and then out of the mirror to Ricky's eyes in those same angles. So by angle, once again, these triangles are similar. And therefore, we know their sides are proportional. We can set up a proportion. So the x corresponds with 6. Since I put x in the numerator, something else from the same triangle needs to go in the numerator, so 19. And the 19 corresponds with 8. So x and 19 are from the same figure, they're both in the numerator. 6 and 8 are both from the same figure, they're both in the denominator. And then I have corresponding parts matched up in each ratio. And there is our proportion, and all we have to do is cross multiply to solve it. So 8 times x, 6 times 19 is 114. And there's the equation to solve. X is being multiplied by 8, so we divide by 8. And you should find out that the flagpole is 14.25 feet tall.